Hi guys, welcome to Learn Electronics Repair. I have a parcel full of stuff here today, and I have Detlef with me also. So we have this. This is from PCBWay.com and it's surprisingly heavy in actual fact and contains all the PCBs we ordered for the various projects we want to work on the channel. 1.7 kilo of PCBs, and it says, strangely enough, 73 pieces, which is a bit odd because we ordered them lots of 5. See, how do you get 73? Yeah.
We'll find out.
Yeah, so I think first of all, let's open the box. Let's see what's in the box, and then we can have a chat, hopefully, with you guys about which projects you would like to see us work on first, and we'll kind of maybe prioritize those ones. Ta-da! So let's have a look. Okay, so one box, and Det is now going to tell me off because a couple of weeks or so ago he saw me using these and he gave me a blade, a handle, the whole thing, the knife, yeah, and I went out to look at somebody's satellite and it's in my toolbox. I still have it,
okay,
but it's on the van.
That's good. So we need to order another one.
No, I just need to get off my backside and go to the van and get it out of the tool bag. However,
I can't see any blood. This is horrible for me.
No, I'm so used to using this.
Yeah. You say this all the time.
So we ordered these, and they took about less than 1 week to arrive
was
here
really fast.
in the Canary Islands. I was really surprised. And they take a day longer than they should have done because last week on Thursday was a public holiday.
As it's always here. There are always public holidays.
Yeah, absolutely. We have 19 a year, and 2 of them are actually just local public holidays in this county, and that was the second of them. So here we have. Oh, well, we have some things here. Let's have a look what they've sent us.
Goodie bag.
Yeah. Oh. Oh, what do we have in here? Oh,
stickers. Really big stickers. Okay.
Yeah, I don't know where they want me to put these. They're rather crumpled, but in there. Well, they ain't going on the van. I don't think they'll go in the window, but there you go. Oh, they'll want me to stick this to my mat, no doubt.
Oh, yeah. Ooh, okay.
Okay.
This is a bit intrusive.
What do you think, guys? A bit intrusive, or? And we have. Oh,
these work.
Yeah, this works.
This is yeah.
Yeah. I don't know if these count as part of the 73. This is another one of these. So I previously tried to convert these into things like a signal generator. Did you see that project? I've actually thought about that, Det. So I think actually when this one runs out, we'll use it first. We'll make another signal generator, and this time we'll use one of your little 8-pin.
Well, one of the SMD microcontrollers.
One of your SMD microcontrollers. Yeah. I mean, we only need that. And
that will fit. Yep.
Yeah, and then we have a capacitor which connects to the injector, which goes in there.
A 412 will fit in there,
Yeah, and just a little touch button. So I think we can make that with 1 component. Is that right? No, 2. We need a capacitor to isolate it from
Gotcha.
the circuit, yeah? So I'm sure we can get a PCB from PCBWay enough to mount that on the capacitor.
Next project coming up.
Next one coming up. So that'll be the signal injector version 2. And we have. It's like Christmas, this is, guys.
Yeah. Chinese Christmas.
Yeah.
PCBWay Christmas.
Oh. Is that a pen?
This is just a pen, I think.
Yep.
And it's working.
And it works.
Even better.
Yeah.
Was this a switch?
Yeah, there's a switch on it.
Okay.
Oh!
No
way! Oh, man!
Okay.
Are you ready, guys?
Light it up.
Wow, man! Does that sound light up as well? Oh!
Ooh.
Yes, way. Wow. This would be even better to put a signal injector in.
Oh, we have a light source.
We have a light source and we have an on-off switch.
And the switches already.
And the battery.
Nice. Yeah. We modify this. This is hackable.
This is hackable, okay.
Yeah.
For those of you who like to join us on our live stream, I think the day you watch this video will also be the day that the next broadcast is on at 5 p.m. I shall put the text on the screen if it is today, because I will publish this tomorrow morning. Okay,
It's Saturday today.
yeah, and we can take this apart. Okay. What else do we have? We have PCBs.
PCBs.
We have
At
many
last.
PCBs. Oh man.
All right.
We have PCBs. We have PCBs. We have PCBs. And we have something else.
What is this?
I don't know. Whoa. The PCBWay Makers Club 3x XL. That might have fit you.
Well, we have to try.
Yeah.
Maybe we have to slim down a bit more for that.
This is a.
But it's white. I can't wear white. It won't fly. PCB, send us in black, please. Next time.
That's more my size.
Yep, looks like you in the Maker Club.
Why am I a 3x XL normally? I'm just large, yeah.
Yeah, this it's loosely fit.
Loosely fit. Okay. Shall we do some work now, guys? Thank you, PCBWay. That's really appreciated. We just move all the various stuff we've been playing with.
Yeah.
Okay.
There's a big pile of stuff now here.
Yeah.
Yeah. Oh no. Come on, let me put this in.
Yeah.
Being a good assistant here.
Okay, so we definitely have a lot of things to play with here. Let's see what we've got. Some of these things are more analog, some are more digital, Det Street. So we did talk about some of these things also on the previous video, but this one is, do you know what this is, Det?
A transformer.conversion finder.
Yeah.
It says on the video.
It does. So, you know how you have these little dots on schematics? I don't know if you've noticed them. So it's saying that when, for example, the primary is this end of the coil going positive, the dot on the secondary is also going positive, so they're in phase with each other.
Yeah, gotcha.
And, yeah, what this thing is, you attach 4 little terminals on here, you just connect the primary, the secondary, and then effectively, if this end is in phase with this end, this LED lights up, and if that one's in phase, that one lights up.
Clever.
Yeah,
That's a clever little project.
it is, isn't it? Yeah,
I like it.
this uses some CMOS chips. So basically, you've got a 555 timer.
Yeah, for some square wave.
Some square wave,
yeah.
that's right. Yeah, and then it uses LM358, which monitors the ends of here.
Yeah.
Converts it back into a 5-volt signal.
Yeah.
And then what this does, this is OR gates.
40.
Yeah, 40-50. 40-30. It's a quad OR gate.
Electrodock. They have the 40 range.
4030. This is an OR gate, guys.
I believe you.
So basically, the OR gate, but what it says is it's sort of like one end's monitoring here and one end's monitoring there and there, so it uses more than one gate. And it basically says that if this end is high and, or this is high, it knows it's this LED that lights up.
Yeah.
That sort of thing.
Clever.
Yeah, so I want to play with that one fairly soon, actually.
I don't work so much with transistors, with transformers, so this is not so much my alley, but I like the idea.
Yeah. So I'd like to do this one fairly soon, guys, though, about UF, which is an interesting little project, and it might just be useful.
Yeah. And this is all roll-of-the-mill components.
Yeah, just general components. I'll probably have to order the 4030, but everything else I think will have.
Exactly what I was thinking.
Yeah. But if this is an OR gate, we might be able to use something else that I have.
Yeah.
So we have those ones. What else do we have? This is the one that Det and myself worked on, so Det can tell you a bit about this. This is the multi-load.
Yeah.
My lovely knife again. I tell you what, Det. You made the holes in this big.
Yeah. You gave me the somewhere over there. Are the
Size of them?
Look at these. We got over there on the there. On the prototype from Mr. Bleep. This is where I measured.
Oh, I see. Oh, so those fit into there.
Yeah.
Oh, I'm with it. And then you put the connection from there back to the board.
Indeed. Yeah.
Okay, so what does this one do, Det?
The multi-load is a thing we talked about a lot, and this developed from a simple USB load, and we extended this quite a bit. Richard wanted to have more power. This is why there are some hefty transistor things, and we went for the naked traces here because we wanted to have a higher current possibility here.
Oh, so we can put like a thick piece of wire along here, for example.
Yeah,
solder.
you simply put solder on there.
Or solder on them, yeah.
Yeah. You probably could have ordered them with a thicker trace. Normally this is 1 ounce, and PCBWay you can go up to, I think, 16. So this feels like the PCB gets this sick about.
Yeah. Oh yes, that's right. But I remember now when I ordered these, because these were the I won't say prototype, these were the revision 0.1, yeah. So it was a lot cheaper to get the PCBs like this with just the normal 1 ounce. Is that 1 ounce per meter? Is that effectively what it is?
I only know the
per square meter.
Yeah, this is something I'm not sure how they measure that.
It must be, if you think about it.
It must be square meter.
Yeah. If you say it's 1 ounce copper, it means that if you have a square area, whether it's 1 meter or whatever it is, that the weight of the copper in that square meter, if you weighed it, would be 1 ounce.
Yeah, probably. This would be the thing. Yeah.
And therefore, that is proportional to the thickness of the copper. Yeah.
We went for a multitude of possible connections. We have the banana plugs. If you don't like banana plugs, fine, don't use them. We have these big pads here, ground, and what's the other thing, VCC.
Yeah.
You can use these, or you can use a USB plug. Probably not at the same time. This is not a good idea.
No, probably not.
And this was the thing we thought about the daughter board with the display on it.
Oh, this is it. Yeah, display board here. Yeah. So this had 2 attachments. It's all coming back to me now. So this effectively is a load that's powered by obviously what you are loading, either USB or say banana plugs. The single transistor version we did was about 35 watts and we were managing to get out of it. So this should do about 140 watts load.
Yeah, roughly.
The LM358 effectively is like a constant current source, but it's a constant current sink. That's what this thing is. Yeah, that was it. And then there was this daughter board that Det was working on, the PD decoy. So from AliExpress, we bought some cheap.
We got the PD decoys because we wanted to be able to switch to different voltages from USB PD, and
So this is a thing on your USB power supply where it says 5 volt, 9 volt, 12 volt, 20 volts. Yeah.
We did a video where we played around with the little PCBs for that.
Yeah. And this one, the little, this is your little microprocessor.
This would be a microprocessor with a little display on it.
Yeah, so this was displaying voltage, current, and watts.
And load, the load.
Yeah, the load, yeah. So do you need another PCB for that little monitoring?
Yeah, when we know this works and we're sure everything is okay on there, I'll design the little PCB for that and do the programming for the CPU for that.
Okay, so that's a joint effort, guys. So you'll see this one on both Learn Electronics Repair and on Det Builds Stuff, where he'll be talking about the software, the firmware, if you like, how to develop that. So if you guys are interested in seeing that one fairly soon, give it a thumbs up or just a shout in the comments and let us know.
Let us know, please. This is the thing we'll try this first because when we need to be sure the hardware works. This is a thing how I work. I need to do the PCB design pretty early to find out, does my layout work? Does it do what it should? And are we fine with a load on here? This would be a very interesting test. And when we're fine with that, then I go to the next stage. Next stage will be the display board.
Okay. So that one you guys can vote for. I happen to note in here is something very similar. So this is one of PCBWay's shared projects. This is another load in actual fact. So this is one of these projects that somebody has uploaded. So they get 10% commission from the sales of the PCBs. And this is a load that's designed to use a LJ775 heatsink, which are very cheap and easy to find off old computers. This one has a little processor chip on here.
Let me guess, 328 Atmel.
Do you know, we'd have to go and find the project. We can do that now if you like and have a quick look on PCBWay.com.
Well, we could do that.
Okay.
See you in a bit. So this looks like a really nice schematic. This guy's put some thought in there. I like this. The power supply and filtering is done very well, from what I can tell without going into depth here. Some filtering, some buttons. The CPU isn't an Atmel, it's an STM. I have a programmer for these, but I'm not that familiar with them. So we maybe have to put some thoughts in there before we can get anything out of there.
Mm-hmm.
And this is okay. SOD. This is a standard adapter. Down here, you see the SOD. This is how you program the STM CPUs.
Mm-hmm.
We have hardware for that.
Okay. So we have to order the processor?
Yeah, we have to order these. I can check my parts, but I only have a few lying around. Maybe we'll get lucky. These long numbers here, all of these letters matter.
All of this?
All of them, because there's so many variations.
Okay.
Yeah.
Then we have op-amp circuitry. So this is constant current control. Yeah. So again, it's like a constant current sink rather than a constant current source. And he has an OLED display on this.
Yeah, he has a little display. I saw on the layout that this is connected via flex cable. So I tend to use more like the little modules where you only have 4 pins with that. This isn't anything fancy because you see there are only some caps on the rest of the pins. But to my liking, it's way more easier to solder 4 normal pins than the flex cables. But I know somebody who can do this.
Okay. So this is the PCB, and this is what Det was discussing about how the OLED attaches here with a flex cable. Yes, I can solder that, but we're thinking with these projects from PCBWay, and I've done this before myself, is to modify and improve the projects where required. So this one we can put together. We definitely need to order some stuff. It's going to be a fairly involved project to build, but I think it's an interesting one. Especially we can do this kind of in conjunction with this much simpler device that we designed and see if there's any real advantage to this compared to this one.
Yeah. See, this is a different approach. This is highly integrated, all SMD components, and we were going for the opposite. We're going for through components and going for more a beginner's unit there.
So really the idea of the multi-load is something you can put together probably with salvage components. You may have to buy the TIP 122 transistors. These are Darlington transistors, by the way, so you pretty much have to have the right ones, but anything other than that is just common LM358 resistors, capacitors. Okay, so we can do these in conjunction, or we can start this one. We have what we need now on this one, as we mentioned. This one, guys, let us know what you think about it. We will definitely do it. I think it's very interesting. On the PCBWay website, there is the firmware.
Yeah, we saw the firmware.
Well, the source code, in fact, the source code was there. So I think this is something interesting we can play around with and see what we can get out of that. Yeah. Okay, so that's those. We have a few more things to play with. This looks like another power supply. This one. Oh yeah. Yeah, guys, there's always a fascination with power supplies. I am still playing with the previous one. I saw this one. This is a 0 to 20 amp, 0.6 to 32 volts. So it won't go below 0.6. That's interesting. Open Prime TV. This is the guy who designed this one. Uses TIP 35s. So yeah, this is another power supply. We can put that together and have a look to see how that one goes. This is fairly, this uses a TL494. You see it there? This is the same chip that they use on ATX power supplies.
Yeah, you're right.
Yeah, to drive the power supply. So this is something we can get. You know, now thinking about this is actually a switch mode type power supply. I remember now. So I think the transformer here is something we can salvage from an ATX power supply. Let's have a quick look at that one on PCBWay. Okay, so here's this project. This is a contributor from Ukraine. So again, he will get commission from the PCBs we ordered. We can see the PCB here. We have a video. He's showing the built device, and you can see this actually uses coils, which is winding. He's got a former here. we can just get a little bit further in. Yeah, we can see the circuit here. If we just get rid of this bit. So you can see this is effectively a switch mode power supply. Okay, there's the outputs. Talking about coils again, and I think we actually have a picture of the actual transformer he winds. Yeah, this thing down here. So guys, this could be a lot of fun. I've never wound transformers before, and Det, have you ever wound a transformer?
Only for a jewel thief.
A jewel thief?
Yeah.
Steal things? Or?
Yeah, it steals the last jewels of a battery. Yeah.
Oh, right.
Yeah.
That's strange, because jewels is actually like a type of beer that you get in pints in England. Maybe it steals them. Or the people tend to call it jowls there for some reason.
Maybe it's Joel.
Maybe it's the same guy. So, yeah, we think this is a prime example of something spectacularly going wrong with this one.
We need to build the little tester for the direction of the coils.
Oh,
first,
yeah, of course. Yeah, that's true. That's in the phase, yeah. So he's saying here output voltage 0 to 35. He said 0.6 to 32 on the PCB for some reason. Output rating 25 amps. It said 20 and peak over 30 amps. Okay, automatic active cooling in the form of a cooler. Okay, so and short circuit protection. Okay, so that's that. I think that'll be a lot of fun again. Okay, I'm not quite sure how successful, but
we'll find out.
We will find out.
Yeah.
Det was saying he hates there wasn't a schematic. I'm sure there actually is a schematic on there.
It's in the video.
It's in the video.
But in the video, man, give me PDF anytime, but not in a video.
Okay, well, maybe there was one.
Not good style. There's no CPU on there, so we don't need any source code, but a schematic would be nice.
Okay, I won't ask if you guys are interested in seeing this, because certainly the more sadistic ones amongst you want to see us going through the pain of actually trying to build it and make it work, okay?
Yeah, but he did a good job in marking all the components.
He did do a good job, so hopefully that will be some fun. Again, this one, we'll have to order some transistors and figure out how to wind the coil. Mainly is going to be the fun on that one. Sure, you guys will have things to say about that in the comments below. Yeah. I won't ask, because I know you want us to do it. What else?
No way out, guys.
No way out.
No, you gave me the wrong one. This is
oh,
I'll take this one.
Sorry, I passed the wrong thing. Okay, well, what is this one then? So this is a something else. What is this one? This is another one by the same guy.
It is.
Open Frame TV, and this is again some kind of like switch mode power supply built using salvage parts from an ATX power supply, I'm sure. Let's have a quick look to see what this one actually is. Yeah, so this is another similar looking thing from the same guy. It's a switch mode power supply. This one generates up to 600 watts. I think it's actually a fixed voltage output one, but I've had several people asking me if I can build switch mode power supplies. I think the reason I was interested in this one is just out of interest to see how it works, just to learn about switch mode power supplies. And there's no better way than building something like this and having it blowing up.
Is this mains powered? Yeah, it is.
Yeah, it's mains powered, yeah. So this is the transformer here. It will be isolated. Perfect board for the switching power supply.
600 watts, yeah. That's the thing.
Okay, so we have that one to play with.
Again, I hate, look at this down there, there's technical details and components, and there's nothing. Man, please supply us with a schematic, please.
Good question. Maybe if we go to his video on YouTube,
probably,
and actually go to YouTube, we may find there is more information here. Okay, universal power supply, more.
Schematics. Okay.
Schematics, yeah.
Some schematics and the description of the board.
Yeah, and this will be for the other one as well if we go to his YouTube channel. So credit where it's due. This is the guy, Open Frame TV, okay, from Ukraine. So let's support this guy. Let's build these things, and if they work, yeah, let's. What's he saying? He's saying to create the videos, you need a budget, and my finances sing romances.
Man, I do bad English, but I have no clue what he want to say.
No. I think he says ka-ching.
Okay.
Okay, guys, that's something else we can play with. Let's have a look at the rest of these PCBs. Here's something a little bit different. I know what this one is because it says on it, it's a subwoofer tester. So this is a very accurate sine wave generator from 1 or less than 1 to 50 hertz, I think it was. And basically it should generate a very accurate sine wave at a very accurate frequency. This one uses a MSP 430 G2402. What's that? Let's have a look. What's this stuff, Det?
I have no clue. MSP doesn't sound like a CPU, but I was thinking when you said this, just a sine wave for 0 to 50 hertz. Why not use a microcontroller for that? A microcontroller and an amplification stage.
Well,
there's an LCD, so this thing has an LCD. Probably.
Yeah, it fits across there.
And these are all under the LCD.
All these MCP. I would have said the answer to that, and you can possibly.
Oh, there must be a CPU mode, DEC ink level.
Yeah. I would have thought that analog circuitry can generate a more accurate sine wave than the microprocessor ever could. Is that right? But I suppose CD players told us that isn't correct.
Well, I'm with you with that, because even a CD player always has a step. But do you need these precision?
For testing subwoofers? I don't know.
I don't know either.
I mean, generally speaking, you have analog amplifiers, maybe a lot of Class Ds these days on subs, to be quite honest. So, guys, audio files, comments. Yeah.
Let us have a look at the schematics if there was one.
Right. So the LCD 1602 and this thing in the middle. I'm sure there's a schematic. Let's have a look.
There must be a microprocessor. This is probably one.
Okay, so here is subwoofer tester. 40 hertz, up to 40 hertz at 0.1 hertz steps. Precision low frequency generator. Okay.
Oh, the sine waves produced by stepping through a table of 64 values and sending them to the MCP blah blah blah. A 12-bit serial DAC uses SPI. This sounds unnecessarily complicated.
Okay.
Sorry.
So this is again something very much for Det to explore, I would think.
Yeah, I want to know what the to program the MSG 43 blah blah. You need a precision low frequency to launchpad with 3 wires to make a standalone. Yeah, this sounds very, very. I never heard of the MSG 430 CPU.
Okay.
Yeah.
So those of you out there who have a little bit of sadistic streak, in this case you can direct it towards Det, because this is very much his sort of thing. This guy's in Nevada. I'm sure we can get in touch with this guy.
Hey, Dad. Thanks for
we have the schematic here.
Schematics, please.
So we can have a look at it. Oh, I'm having to log in.
We can do that.
We can do that, I think. Yeah, we're in. Let's have a look.
And there's a bomb. Oh, nice. Okay, so we're not stuck with.
And this is the schematic.
Yeah, this is some kind of CPU. Yeah.
As I read that, he's almost was saying like it was kind of like just reading through a RAM, which has got a table of values. It's made a sine wave, kind of like sequentially rather than like a CPU. I don't know if that's the case or not, but it obviously has something to drive the LCD.
What I find interesting, he says a table of 64 values, and it puts it through a 12-bit ADC. Why? If we only have 64 values, it's a 6-bit sine wave. And you can do an 8-bit sine wave with 255 values, 256 values. Yeah. And put it directly into some small ADC.
So, guys, I know this will appeal to a different subset of you guys than some of the other projects, so let us know what you think about this one.
Yeah.
Again, if you're around this evening on I'm saying this evening, it's Saturday today, so Sunday, this video will be up in the morning. This evening, we have the live stream at 5 p.m. London time. So come along, let's talk about some of this stuff.
Oh yeah, that would be nice.
Yeah, especially if any of you guys may be interested in getting involved in this sort of thing. Yeah. We could possibly let Det off the line there. Yeah. Okay, so we have a few more things to look at. Okay, so this one says sound B on it. Oh, this is a 300 watt dual power supply. This is a power supply, another one for plus and minus volt rails. I ordered this one. I thought it might be useful when we're working on mixers and amplifiers where we got a problem with the power rails, maybe problem with the board. So this is effectively a power supply for either when you're working on audio projects or if you are repairing audio devices. 300 watt. Again, it's a switch mode power supply. Okay. So lots of switch modes we can play around with this time.
Aren't you analog guys always saying, "Oh, we don't want to switch mode. We don't want to do switch mode because switch mode is so noisy." And,
Again, it'd be interesting to look at these because if we make the thing and it is noisy, because it's a project like this, we have the Gerber files and everything else. This is an ideal tool to learn. To learn how to increase the filtering, how to improve the design. Again, I think a lot of you guys be interested in getting involved with that one. So that's another one. I mean, these projects, these will last us till the end of the year, yeah? Sure. Into next year. This is not all going to be built in the next few weeks, okay? So some idea of what you'd like to see us do first. Partly, it will also depend on what we have the parts for first. Okay, so that's that one. And we have some small PCBs. Well, this is the next largest one. So this one, I've been waiting for these. I don't have to show you the schematic for these guys. I want to make a video. All you need to know about op amps to fix stuff.
The op amp tests.
The op amp testers. Well, they're testers, but they're also
test circuit, learning circuit.
A learning circuit. These are a teaching aid.
Yeah. Oh, I saw this. This is really nice.
This is really nice. Okay, so here we have it, guys.
I'll probably steal one of these PCBs from you.
You can have one of these PCBs, my friend. Okay, so it's upside down. Dual op amp test board. So you put the op amp in here on the socket, and then you can play around with the resistors. So you see, it's made a layout for an inverting and non-inverting amplifier. And the idea of this is you can solder components, or you can put little sockets in here where you can just plug resistors in. And effectively, that's how you would see the circuit on the schematic. And you can play around with the values of components. But the actual op amps go here on sockets again. So if you accidentally blow something up, you just put another op amp.
This is really nice because the caps at the inputs, for example, the pitch is exactly so you can use a two DuPont pins in there, do a short circuit. So if you don't need the caps and the input, you simply cross them over. This is nice.
Yes, nice. So this really, guys, is for one or more videos, probably more than one, I will be making on op amps. This will probably be fairly shortly. I've been waiting for these to arrive. And we can also easily with this play around with different op amps. We can look at the different characteristics, fast slew rate and various things. So yeah, again, guys, this one is a teaching aid, but I'm interested to know what you guys might like to see me doing with this. And hopefully very soon we will know all we need to know about op amps to fix stuff. Nice.
Yeah, absolutely.
Christmas is almost over, but we still have a few more. So this one, Mr. Bleep.
There he is.
There he is. So this is the standalone bleeping multimeter. Yeah, single bleep on the diodes and continuous on the short. And it'll determine if you have a Schottky. This is very much something for Det to be involved with. Anything else you'd like to say about this project, Det?
Oh yeah, I think everybody on the channel saw these videos. This is a short bleep for diodes and a long bleep for. This is a continuous. Normally you test for continuously and you get a long bleep, but if in this case if you test the diode you get a short bleep, and it's a Schottky. It's a different bleep than a normal diode.
So these are nice.
Yeah, we did this on a little Tiny 85. And this was a collaboration we just came up with, and this is this is revision 0 of those. So revision 0 always says let's try out if everything works, and we could probably get this a bit smaller in the final run, but we probably don't need that.
These were designed to make them easy to assemble. For example, like you can use either like a TO220 or a TO92 voltage regulator. It was just make it easier out of salvage parts you could build this. I know a lot of you guys have been waiting for the code for the version we built into a multimeter, into a little Unity. I will link that from this video. I will also link you to Det's channel, but you'll see that in the video descriptions for all my videos anyway these days. And Det will now be working on the code on this, and you guys can have the source code there.
Yeah. For all you guys waiting out there, this is not to keep you waiting. Sorry for that, but I want to be final with the code here, and we're not final right now because this Mr. Bleep is a different beast than the one we integrated into the
multimeter.
The multimeter. So there are two code bases, and this needs to be done first. And there's the RGB, the totally useless. There's RGB on there.
Yeah.
And I want to have this finished before I go any further.
Yeah. Yeah.
We actually have the little voltage monitors for these already. They came from China. And so we can sense the voltage. This is becoming a complete voltage meter.
Yeah, a continuity and diode mode test meter, basically.
Yeah.
So the reason this is different on the one which I built into the multimeter, that one, the probes on the multimeter, neither of them were referenced to ground, which the ground of the battery. So it had to have different code, effectively two differential inputs. Yeah. Again, we can probably have a chat about this one on the live stream.
Oh yeah, we can do
later. Because on the one we built into the multimeter, a lot of people are very interested in how we can improve the protection on that. For example, if you accidentally connect it to a board that's powered up.
Oh yeah, that would be bad.
That would be bad. So I can say with good certainty, this project and the first one we saw, the polarity tester for the transformers, will be the two we're going to do in September because we have the parts for them already.
We have all the parts for this one.
Yeah. So that one, guys, you'll see next month. What else do we have? We have 4 more. Hey. And that's Det's beast now. I did the multimeter version, so that's Det's thing. This is some little boards. Oh yeah. So we have a few boards here now which are all basically very similar. These are from Easy One. This is one of them. Let me see if I just find the other ones from him as well. In fact, possibly all these are from him. So this guy, he's been building various inverters. So 12 volt to 220, 12 volt to 240.
Oh.
Yeah. This one is basically just using discrete components. He has one, I think, using the same sort of chip again we put into the TL494s at the ATX. So I ordered a variety of different boards from him. We can have a play around with inverters.
2 MOSFETs.
Another set of Mr. Bleeps.
Oh, Mr. Bleeps?
Yeah, Mr. Bleeps has got 2 sets of PCBs, by the way. That's something else.
Why? Well, I'm not complaining.
Okay.
You can use them as a keychain. Look,
Yeah. Mr. Bleeps keychain, yeah. Yes, so guys, this is the other ones by the same guy. Again, this is an inverter. One of them he's using a power supply out of an ATX, and I think the other one was something out of like an old UPS or something. Again, these are fairly simple to build. I'll probably have to get the right MOSFETs, but yeah, just order a few MOSFETs so we can get on and play around with those. I'm interested again to see these because these will generally give pretty much like a square wave output, I think.
They look at the MOSFETs over there. These 2 MOSFETs, so this kind of be square.
Exactly.
Yeah, there's no way to get this in sinal wave.
No. But I'm thinking if we use like an LLC type circuit, yeah, something like that. So again, guys, because we have the Gerbers for these, and we have PCBWay or happily send us future PCBs, you know, they sponsor the channel, so we get these PCBs sent to us free of charge, which is great. We can do this sort of thing. So again, we can talk about inverters and we can play around with the stuff and see whether we can develop something better.
They remind me of the thing we had on the electronics channel with the 12 volt adapter for the 75 watts, and we all were very, very impressed by the 75 watt that worked in a 12 volt to 220 thing. Yeah,
for those of you who didn't see that live stream, so it was a little thing that effectively plugs into the cigarette lighter socket in the car, and it said it gave 75 watts of 220 volt AC. and we actually loaded it to 70 watts, and it was absolutely fine. It wasn't even warming up.
And all three of us, Carlos, Richard, and me, and we always going, no way this is going to work, and it worked.
And it worked, yeah. Amazing. You can watch those old live streams, by the way. They're there to watch as videos. So there's those, and then the last one is something that Det worked on based on something that I came up with.
Yep.
So I'll show you what we have. Back in the day, this is old. This is before you moved it. This is almost a year ago we talked about
I did this on my notebook when I was here on holidays.
Yeah, which was almost a year ago. So this is a breakout board for HDMI. So at the time I talked about this, I actually made the all you need to know about HDMI to fix stuff. And we have some breakout boards here, okay? You can see them there. So here we have all the various signals.
This will be pin headers. Yeah.
For the pin headers, we have your HDMI in and out, powers. These areas are actually for adding other components to play around with this.
Just C of holes. If you want to put something on there, you simply solder it on there. There's no connection. You just have C of holes. So if you want to do some resistors or something, you can put them on there. Yeah,
or add a door to wood. I had some crazy ideas that we could do some things with this. Like, for example, all these are LVDS, the like differential signals, plus and minus. And it's possible that you have a faulty HDMI where one of the LVDS signals is missing. So you've got the positive but not the negative going. And I had some crazy ideas that you could actually reconstitute or recreate the missing signal from the one. So if you've got the positive going one, you could recreate the negative going one by adding some circuitry to this and effectively fix the problem. This is if you had, for example, these LVDS come out of a GPU directly.
Gotcha.
The other thought I had, it may be possible because the LVDS signal is synchronized to the clock signal, 100 megahertz. And the rise time and fall time stays the same, it's just the state. And I had, again, some crazy ideas. It may be possible to recreate the clock signal from the data. Not from the actual data, but from where, by the point that the data, the LVDS, where it switches over, is at the same point where the clock.
Yeah, if you know this 100 megahertz, you simply need to synchronize the 100 megahertz to the
where it changes over, and probably halfway in, because it must sample the LVDS signal kind of like halfway in between where it switches high and low. It must at some point then sample it to say, is this effectively a logic 1 or a logic 0? And that's synchronized by the clock. And I was wondering whether it was possible to recreate the clock signal if you have a fault where all the data lines are there but the clock isn't. Guys, these are some pretty crazy ideas, but I talked with Det and Carlos, and they're pretty crazy guys, and they said, hey, you know, that might be possible. So that's why we ordered these, as well as being very handy, we thought, to test for various faults on HDMI. So once again, guys, very interested to know what you think about these ideas we have. Are we really crazy? Tell us if you think we are, but I suspect somebody else will come on and tell us that we're not. And that's just called personal opinion. Okay, so that's everything we have here to play with. There are a few more PCBs we want to order, so I'll order those as well. They just didn't get tagged onto this order, but I think we have enough stuff there to keep us going for quite a few months.
This will keep us busy,
Yeah. Okay, so hope you enjoyed that. I'd just like to thank PCBWay for sponsoring this video very kindly. They allow us to do these things, but I think we're all learning a lot. And Det, thanks my friend for coming along again with your input to this. And without doubt, with Det's input over the last couple of months now, you guys know, we're getting much more involved with these projects. 2 heads are far better than 1.
I think so,
Yeah, and all your heads in addition, that's better than anything. Okay, guys, so look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.